Simplifying radicals, including variables. Again, what I want to do is I want to break up each expression inside the radical by writing each of these as a product of perfect squares. When I do that, again, I'm going to look at the number 54. I'm going to consider all of my perfect squares that could possibly divide into 54. What the perfect squares I'm going to consider are 4, 9, 16, 25, and so on. The perfect square that can divide into this number evenly would be the number 9. So I'm going to go to my radical. I'm going to rewrite the number 54 as a product of two numbers. So this 3 is going to stay outside my radical. The number 9 times 6 would be my product to give me 54. Now I want to break down the x to the power of 7. So again, you need to consider perfect squares as a product of variables. Well, x to the 7, if I consider a perfect square, x squared would be a perfect square. So what I want to do is I want to write this as a product of perfect squares where my exponents will add to give me this exponent value. So x to the power of 7 can be broken down to be x squared times x squared times x squared times simply x. So if you look at my exponents, 2 plus 2 plus 2 plus 1 will give me an exponent of 7. So I've just rewritten x to the 7 as a product of x's, where x squared, and x squared, these are all my perfect squares. I am now going to do the same thing with my variable on y. So y to the power of 4 can be written as a product of y squared times y squared. 2 plus 2 is going to give me 4. Once I've broken this down into a product of perfect squares and whatever is left over, now I'm ready to take those perfect squares and bring them outside of my radical. So what you want to do is you want to highlight or identify all of my perfect squares inside my radical. 9 is a perfect square, x squared, x squared, x squared, y squared, and a y squared. All of these values that I have highlighted are going to come outside of the radical. So when I do that, when I bring 9 outside the radical, remember I am taking the square root of this value. Square root of 9 would be 3. So I still have this 3 outside the radical, and it's being multiplied by whatever I am bringing outside. So I'm going to multiply this by the square root of 9. I'm going to multiply it by the square root of x squared, which in that case is simply x. I'm going to multiply it by the square root of this x squared, which is simply x. And I'm going to multiply it by the square root of this x squared, which again is simply x. Now I'm going to take the same thing and take the square root of my y squared, which is simply y. Square root of y squared is simply y. So all of these values I have brought in outside of the radical. You're going to ask yourself, well, what is remaining inside of my radical? The 6 and x. These were not perfect squares, so I cannot bring them outside of the radical. So now I just want to simply simplify this expression outside the radical. So 3 times 3 would give me 9. X times x times x would give me an x cubed. Y times y is a y squared, and I'm left with root 6x. And this is how you would simplify radicals containing variables.